All right, welcome to The Explainer. Today we're doing something a little different. We're going to look at artificial intelligence not from the perspective of a creator, but from the perspective of someone who wants to break it. We are diving into an AI hacker's playbook.
So this is the big question, right? We're always hearing about how AI is this incredible engine for progress, but what happens when that very same power is deliberately aimed at doing harm? How do you actually, weaponize an AI system?
And look, this is not some sci-fi fantasy. We've already seen AI systems, even without a hacker's help, cause real tangible harm. We're talking about systems that unfairly screen people out of jobs, that decide who gets healthcare and who doesn't, and they get caught in these awful bias cycles of over-policing. The stakes here are just incredibly high.
To figure out how to break an AI, an attacker has to first know how it's built. They don't see the AI development process like a project manager would. No. To them, it's a blueprint, a treasure map full of potential weak spots just waiting to be exploited.
Every single AI pretty much follows these three big stages. First, you figure out the problem, and you gather up all the data. Second, you actually design and train the model. That's the brain. And third, you deploy it out into the real world and you keep it running. For a hacker, each one of these is a door. Let's think of them as the three acts in our attacker's playbook.
So, Act 1. The most straightforward and frankly often the most devastating way to mess with an AI is to go after its source of truth, the data. It's like poisoning the well. If the AI drinks from a poisoned well, everything that comes out of it is going to be poisoned too.
A perfect real-world example of this was Amazon's attempt at an AI recruiting tool. The idea was simple. Just have the AI learn from a decade of their hiring data. The problem? That historical data was already biased against female applicants, so the AI learned that bias perfectly and started automatically penalizing resumes from women. The goal itself was the problem.
And this is where things can get really scary, because that initial bias can create something called a self-reinforcing feedback loop. It's a vicious cycle where the system's own bad outputs get fed back in as new data, confirming its own bias and making it worse and worse over time.
You see this exact cycle play out in predictive policing systems. It starts with biased arrest data from the past. The AI learns this and, no surprise, predicts more crime in those same areas. So police get sent to those communities, which leads to more arrests, which then feeds back into the system as proof that it was right all along. And the loop just keeps going, getting stronger each time.
Okay, so what we've been talking about is called data poisoning, messing with the AI's textbooks before it even starts learning. But what if an attacker wants to be more surgical? That's where model poisoning comes in. This is where they skip the data and go straight for the AI's brain, trying to alter the model itself. And this brings us right to Act 2 of our playbook, building a Trojan horse. Now we're talking about a much more sophisticated kind of attack. The hacker isn't just poisoning the well, they're getting their hands dirty, building a secret flaw, a hidden backdoor, right into the core of the AI.
Researchers have a name for this, neural Trojans. And what makes them so dangerous is that they're sneaky. A compromised AI can pass all the normal tests, look totally fine, behave perfectly, until it sees a very specific, hidden trigger that only the attacker knows about. Then and only then it does something malicious.
So what does this actually look like? Well, this is where it gets genuinely frightening. Researchers proved you could put a few carefully placed stickers on a stop sign. It would just look like graffiti to you and me. And that's the trigger. A self-driving car's advanced AI could see that sign and classify it as a speed limit sign. The car works perfectly on every other street, but fails catastrophically when it sees that one secret pattern.
Which of course leads us to Act 3, the grand finale of the playbook. The attack goes live. This is the moment the compromised AI is out in the real world. The hacker can now trigger the backdoors they built or even find totally new vulnerabilities that only show up once the system is actually run.
50,000. What is that number? It's not just a number. It represents a massive, real-world failure of a live AI system.
It represents over 50,000 patient records that were put at risk. A healthcare AI was deployed, but the team made a simple but catastrophic mistake. They didn't properly secure the access controls.
It wasn't a fancy Trojan horse attack, just a basic deployment error that left the digital door wide open.
And once a system is live, the ways to attack it just multiply. Attackers can hijack the update process to sneak in bad data later on. They can fake the monitoring logs so you don't even know you're under attack. They can slip in malicious code through all those third-party tools everybody uses, or even find flaws in the specialized computer chips the AI runs on. The list goes on.
Okay, that was a lot of doom and gloom. It kind of makes it sound like AI is just hopelessly broken, but it's not. Now that we've read the attacker's playbook, we can start talking about how to write our own, the defender's playbook. How do we build a fortress and actually fight back?
One of the best ways to do this is a practice straight from cybersecurity called red teaming. You literally hire a team of ethical hackers, the red team, to think like the enemy and try to break your system in every way they can imagine. Their job is to find the holes before the bad guys do. And they go up against your blue team, the defenders, who are trying to stop them. It's basically a high-stakes stress test for your security. You know, if there is one single thing to take away from all of this, it's this. Security is not a feature you just tack on at the end. It's not a checkbox. For an AI to be truly secure, that security has to be built in from the ground up, woven into every single step we've talked about.
And that leaves us with one last big question. We've seen that a smart, determined attacker can probably find a way to break into almost any system. So, if everything is breakable, what's it really going to take for us, for society, to truly trust AI with the kinds of decisions that actually shape our lives?